frequency division multiplexing, wavelength and time division. So in frequency division multiplexing, where the channel is divided into, where the link is divided into number of channels. So each channel is carrying one signal, okay, that is having some frequency. Okay, so this channel is assigned with a particular frequency. Only that signal it can carry, other signals it cannot carry. Okay, so you may ask the question, so whenever if multiple signals are traveling in a single channel, so there may be possibility of interference. Yes, no? So this signal may interfere with the other signal that is going here. Okay, so you can just consider. So this is one frequency signal, this is another frequency signal. Okay, consider this is F1, F2 and F3. Okay, so the signals with having frequency, so that specified frequency range, so those signals can travel only in this link. Okay, and F2 signals can travel here, F3 can travel here. Okay, so this is how it is going to make use of the frequency division multiplexing. So here whenever if two frequencies are transmitting in a single channel, so obviously there may be an interference. The signal that travels through channel 1 may interfere with channel 2, or channel 2 signal may interfere with channel 3. Most of the time you already observed that there may be cross talk when you are talking in phone. Okay, you are trying to connect with someone, but the call is connected to somebody else. Okay, sometimes if you have observed the call, when you dial number, okay, it will ring and the receiver will receive, but maybe that is not the receiver you expected. Okay, and that person is also not talking to you, it is already they started some conversation with the other number. Okay, so like this there will be an interference. So now how to avoid that interference? Can somebody tell? I have explained how interference, okay, the mixing of the signal can be avoided. What is the concept we have used? In the last class I told, if anybody knows the answer, just tell me the answer. So you should respond. Either it is wrong or correct, tell me the answer. So how we can avoid the interference, that is like overlapping of the signals, can be avoided in case of frequency division multiplexing. So what is that concept, or what is the term I have used? Nobody knows? Yes. See, I have observed few students know the answer, but still you are unable to answer. Why you are doing like that? Don't do like that. If you know the answer, you just unmute yourself and you tell, or put the answer in the chat box. Anything is okay. Okay. So here it requires to use a guard band. Do you remember I used the term guard band? Okay. So this is some frequency that is unused. So unused frequency, unused frequency. So that is not used, but it is used for separating the frequencies or separating the signals that is traveling through a separate channel. Okay, so something like this, if this is the frequency. Okay, so this is my guard band, this is F1 frequency and this is F2 frequency, and whatever the small stripes you can see here, so this is called as guard band. So with the help of this guard band, so the overlapping or interference of the signal can be avoided. Are you getting what I am telling? Okay, so this part, it is called as guard band. It is going to separate these two frequencies, and this is also guard band. So now F1, it is not going to interfere with F2 because there is a guard band. So the signals that are traveling through this frequency cannot be, we cannot ensure like 100%, because even still today, most of the time we are facing the crosstalk, or sometimes there will be some interference. The whatever the voice you are hearing, it may be not clear. some of all these problems are due to this overlapping. Okay, so where they've used the concept of multiplexing, where multiple signals are traveling in such cases, so this problem arises. Okay, so all this it is explained in the last class. So this is about the FDMA. So the diagrams, maybe I don't know, at least to some extent try to draw the proper diagrams, the waveforms. So this is the actual signal. So that will be sent to the modulator. You already familiar what is the function of modulation in the previous chapter. Okay, so where the original signal is modulated with the carrier frequency, and you will be getting the modulated signal. Okay, this is a second modulated signal, and this is third one. Later you are going to multiplex all these signals. Okay, you are going to multiplex all these signals, and this channel is going to carry all the signal at the same time. That is very, very important. At the same time. Okay, so it is going to carry all the signal at the same time through the channel. From this diagram, I think that point is very clear. Can you see? So if you are considering this is signal 1, this is 2, and this is 3. So all 3 is traveling at the same time. Okay, it is not like that send for signal 1, 2, then 3. No, all the 3 signals are traveling at the same time because each of these signals using its own frequency. Okay, so this link, what you can see here, this blue color, it is a link. Okay, so that is having high capacity, high bandwidth. Through that it can carry multiple signal at the same time. So in that case, so here the technique used to perform this operation is a frequency division multiplexing. Hopefully everybody understood till here. See, understand the concept. The subject is very simple. Don't make it complicated. If you're not understanding, tell me, I will repeat it. Okay. So if I tell demodulation or sorry demultiplexing, the opposite operation takes place. Okay, so this is a signal that travels once it reaches at the receiver side. Okay, so demultiplexing should happen. Okay, so that means it has to filter all this carrier frequency, whatever it is transmitting. Carrier frequency should be okay, it should be filtered. Then whatever the signal we are going to get, that should be delivered to the receiver. You can see that demodulation process, demultiplexing. Okay, the signal whatever it comes, so it has to send to the filters. So what is a filter here? It is just a band pass filter. Okay, so where it is going to specify what type of frequency it has to allow. Okay, what is the range of frequency this filter has to allow. Okay, what is the range of frequency it has to allow. I'm getting some request. 1 minute. Okay, so this filter is going to filter only the frequencies that are specified. Okay, not all the frequencies. So like that, you will be having set of filters for each of the input signal, and it will filter the signal. Then after that, it has, see, filtering is because whatever the input it is coming, it is combined input, combined signal. Okay, it has to be separated. It has to be separated into individual input, individual output signal. And once it is filtered, now you have to do the demodulation. Okay, so once again, don't ask me what is demodulator, because in the last chapter we have discussed in detail how to do modulation and demodulation. Okay, if you have missed or if you have not gone through the topics, you just go through the 5th chapter, ASK, FSK and PSK, and also QAM. So these are the different modulation technique we have discussed. Okay, that's why I'm not repeating how it is done. So now it has to separate the carrier frequency. Okay, and after separating, after demodulating, whatever the signal you are going to get, so that is the actual output, and that should be delivered to the receiver. Okay, is it clear? This process is clear. How FDMA works. Okay, so in the last class I have not solved the problems. Let's concentrate on problem. Very simple problem. So anybody is having any doubt? in this concept FDM. This is theory part. So now we'll just the same concept in terms of problematic we'll understand. Very simple problems. Only thing is you should be knowing the concept. So is it my screen is visible clearly so that you can read the problem? Okay. So here the first problem. Assume that a voice channel occupies bandwidth of 4 kilohertz. Okay. So there is a voice channel, so that is capable of holding or sending the 4 kilohertz the signal bandwidth. So we need to combine three voice channel into a link with bandwidth 12 kilohertz. Okay. So that means you have 4 input signal of half voice channel bandwidth it is available is 4 kilohertz. And also when you do multiplexing, you have a single link. So the bandwidth of this link is 12 kilohertz. Okay. So now from what is the range of frequency they have given? They have given the range of frequency from 20 to 32 kilohertz. Show the configuration using frequency domain. Assume there is no guard band. See, this point is very, very important. Whenever if there is a guard band, so there is a specific some particular frequency should be left to indicate that is a guard band. So here they are clearly telling that according to the given bandwidth, so there is you no need to consider the guard band. Okay, what they have given? They have given the voice channel of input, each input signal, the capacity of the link, and what is the range of frequency. Okay, so let's just take out this. Okay. You need to understand. So now consider modulated each of three voice channels to different bandwidth. Okay, what is the bandwidth they have given? 20 to 32 kilohertz. So this is the range of frequency they have given. Whatever the 12 the channel is or the link, it is having bandwidth of 12 kilohertz, and this 12 kilohertz bandwidth range from 20 to 32. Okay, so now how we are going to make three channels that each channel carries 4 kilohertz of the signal. Okay, so now if it is a first channel, I will start with the frequency C, 20 to 32. Okay, so 22 to 32 means how many frequency you are going to get? You are going to get 12 frequencies. Okay, so that is 20 to 24 kilohertz. It is given for channel 1. Channel 1. Similarly, from 24 to 28 kilohertz given to channel 2. If anybody not understanding, you can just interrupt me. I will repeat it. 28 to 32 kilohertz of bandwidth. Okay, so this is the bandwidth, ranging the frequency from 28 to 32. So for third channel. Okay, is it clear? So this is how you are going to divide into three different channels. So if you have remembered the previous diagram, if this is my multiplexer and this is demultiplexer. Okay, consider I have three channels. Okay, so here the total bandwidth of the link, this is the complete link. So the bandwidth of this link is 12 kilohertz, and it will be able to pass the frequencies range from, this is channel 1. Okay, 20 to 24 kilohertz frequencies are passed in channel 1. So in channel 2, 24 to 28 kilohertz, then 28 to 32 kilohertz. So here they are given very clearly, there is no guard bands. Okay, so that is to separate the channel. You don't have any extra frequencies allocated here. Is it clear? This problem is clear. And here when it comes at the demultiplexer, okay, so there will be a filter. This is demux. Okay, and this is mux. Okay, it should be crossed. When you are drawing, try to draw properly the diagram. I'm not able to take the erase. Okay. So this is mux and this is a channel, and whatever the output here it is coming, okay, as a single signal, that should be filtered. Okay, so where the first filter should filter the frequencies range from 20 to 24. The second filter should filter the signal input signal from 24 to 28, then 28 to 32. So this is how the demultiplexing takes place. Okay, so here there is no guard band concept. If they tell guard bands are allowed, then you have to check how much frequency you should leave between the channels. Is it clear? This problem is understood, everyone? A simple problem. I think I have a diagram. You can just observe the diagram. This is just for understanding purpose. In the exam, if you write this type of answer, that's enough. Okay, if you explain like this, that's all. That's enough. Depending on the marks, you check it. And the same thing, it is pictorially denoted. Okay, so voice channel from 0 to 4 kilohertz. So that is coming, and that signal is modulated. Okay, modulated signal is transferred through a channel with a bandwidth, okay, or the frequency from 20 to 24. The channel is having 24 to 28, 28 to 32, and then multiplex. See what happens when it is multiplex. It is combining all the signals. Okay, it is combining all the signals that range from the frequency 20 to 32. Okay, and this is the link, actual link, where it is connecting the two devices. Okay, that is having high capacity of bandwidth, and that is transmitted. Okay, so normally it is used for longer distance, that is transmitted, and once it is comes at the receiver side, it requires to do the band pass filter. Okay, band pass filter, where you can set the frequency, what range of frequency you want to allow, and remaining all should be filtered out. Okay, so it is specified for each of the filters. Here it is going to remove all the frequencies other than 20 to 24. So here it will filter all the second filter 24 to 28, except these frequency it will filter all other frequency. Okay, so the process is repeats for all the channels, and the final result will be sent to the receiver. So this is the problem they have given, voice channel. So that's why we have taken the example of this as a telephone. Okay, so any queries with respect to this problem? Yes, any queries? Any queries? Understood? Something you respond? So when you are there in the class, you should respond. Okay, so next we'll move on to the second problem. Okay. So I will go through one or two problems. So remaining all, you just try to go through the textbook and try to solve it. Simple problems. Only thing is understand the concept. So let's go to the second example of problem. So 5 channels. Understand the question. Understand the question. 5 channels. Very clearly they're telling the link is divided into 5 channels. Okay. Each with 100 kilohertz bandwidth. Okay. So that each channel it is having the bandwidth of 100 kilohertz are to be multiplexed together. That means all the 5 channels, the signal whatever it is going, so that should be multiplexed and it should be sent. So what is the minimum bandwidth of link is there need to be? Okay, what is the minimum bandwidth of the link if there is need for guard band of 10 kilohertz? Okay, so in this problem they are telling you need to leave 10 kilohertz to separate the channels. Okay, so that is called as guard band between the channels to prevent the interference. Interference means like overlapping of the signals. Okay, if this is the case, how it can be done? What is the solution for this? So there are 5 channels. We need at least 4 guard bands. Okay, so I will show the diagram. 5 channels to separate that we need 4 guard bands. So this means that the required bandwidth is the total required bandwidth. Okay, so 5 channels. Each channel it is having 100 kilohertz bandwidth. It requires 100 kilohertz bandwidth plus we need 4 guard bands. Okay, let me just show you if this is a minute. One, two, three, four. There are 5 channels. Okay. So here you can just see to separate each of the channel. So this is one guard band, and this is the second one, 2 and 3. So total how many guard bands you need? So you need 4 guard bands. Even they have given, so the guard band, the frequency should be living for guard band, or the bandwidth to be left for guard band is 10 kilohertz. So that means 5 channel, so each of capacity 100 kilohertz plus you have 4 guard bands each of 10 kilohertz. So what is the total you are going to get? 500 plus 40. Okay, so the total capacity or the total required bandwidth is 540 kilohertz. Understood? How much bandwidth is required? What is the minimum bandwidth of the link is required if there is a guard band of 10 kilohertz? Okay, so this is another way of representing the diagram. You can just observe. Okay, so this is one channel, this is the second channel, third, fourth and fifth. Okay, and each channel you can just see their white space. So this is called as the guard band, where it is going to separate each of the signal from the interference, and this is of size 10 kilohertz. 10 kilohertz. Okay, so this is 500 plus 50. Is it 50? No, it is 40. So total 540 kilohertz minimum bandwidth is required for 5 channels, with the minimum bandwidth of guard band is 10 kilohertz. Okay, similarly there is one more question with respect to a satellite channel. You can just go through this also, very easy to understand. You just go through this problem. Okay, so like how you can represent the analog carrier frequency in terms of hierarchy. I will just show you. It is not like that only one level you are combining. See, when the devices are connected for longer distance, okay, anywhere in the world. So in such cases, so this type of hierarchy is required. It is not always what I explained, just one level of multiplexing. Okay, so whatever we have discussed here, it is just one level of multiplexing. Okay, so it is not the case only you are going to use this. Sometimes it requires to go for, okay, it requires to go for hierarchy of multiplexing. So you can just observe the different levels. So one of these hierarchy system used by telephone company. Okay, so whatever the hierarchy I have shown, this is used by one of the telephone company, and each of the hierarchy they have given the name. The first hierarchy it is called group, then super group. Okay, like how we'll be having the priority, and based on that you are going to specify the hierarchy in the same manner. So your first hierarchy we call it as group, super group, then master group, then jumbo group. Okay. So what exactly in this example it is happening is there are totally 12 voice channels are multiplexed into higher bandwidth line to create a group. Okay, the first hierarchy. Let me just go to the diagram. Okay, so 12 voice channels are combined and formed a group. Okay, so this is first level of multiplexing. This is called a group. Then similarly, so 60 voice channels are grouped into, so this is grouped into 5, and this 60 voice channels are grouped into 10 super groups. Okay, and it is for 600 voice channels are grouped into 6 master group. Then 3600 voice channels are multiplexed to form the jumbo group. Okay, so it is just in a hierarchy of how the multiplexing is done. Okay, this is called as funnel of hierarchy. Okay, it's not so important, but you should remember that multiplexing is not done only at one level. Okay, this is level 1. Okay, if those devices are connected far away distances, in such cases, so there will be hierarchy of multiplexing takes place. So once it reaches at some point of place, so it has to perform the demultiplexing. Any queries? Okay, so I have already told in the last class the main application where they are going to use the frequency division multiplexing is AM and FM, that is the radio broadcasting. Okay, it is mainly used this technique for radio broadcasting. Radio uses the air as a transmission media. There is a special band from 530 to, okay, so 1700 kilohertz. Okay, so within this range, whatever the frequency it is there, so that will be assigned for the AM radio. Okay, so all radio stations need to share this band. So the range of frequency that can use from 530 to 1700 kilohertz. Okay, for each of the channel there will be a specific frequency assigned. Okay, so here AM station needs 10 kilohertz of bandwidth. That means each channel requires the minimum bandwidth. Okay, so this is all about the application of FDM. So still you can just go through the details how the receiver side demultiplexing is done. Okay, so receiver receives all the signals. Yes, if you are taking your radio, so you are able to receive all the signals. But if you are tuning to particular frequency, then it will filter all other frequency. It will play the audio only which is selected, which frequency is allowed. Okay, from that channel you will be able to listen the song or the audio. Okay, so all other signals will be filtered out. Okay, so that normally we call it as tuning. Okay, so you're going to tune to different frequency. When you're doing that, so you'll be able to uh, get the desired audio whichever you like, and you can just set for that. So what is the important thing you need to remember here is, so it is not like that it will carry only one signal. No, at your station you will be able to get all the signal, and to whichever the frequency you are going to tune. Okay, so only that signal you will be able to receive. So all other signals whatever it is arrived, that will be filtered out. Okay, if you tune to other frequency f2, then you will be able to receive the signals related to that particular channel. Okay, and important thing, so you may get objective type of question, either maybe in your competitive exams, okay, or it may be for the quiz what I am going to give. So multiplexing is done at the data link layer. Okay, so you always remember this process, whatever I have explained, all the methods, it is taken care at the data link layer. Data link layer is responsible to perform all these operations. Okay, so that's all. There is one more problem. I'll just leave that problem to you. So just check it. I will move on to the next topic, that is wavelength division multiplexing. Go through the problem. Okay, don't expect to solve me all the problems, whatever it is there. So I will just give one or two problems. Remaining you just go through. If you have not understood, so we'll discuss those problems in the next class. So next method is wavelength division multiplexing. So in short we call it as WDM. Okay, so it is called WDM. Okay, so this WDM is designed to use high data rate capability of fiber optic cable. Okay, see, I think we don't have this chapter for the syllabus, that is different types of physical. Not this chapter, just a minute. I wanted to show the different types of cables. Transmission media. So there is one chapter called transmission media, chapter 7. Okay, so that is not part of syllabus. I am not going to touch that, but whenever you are free, just go through that. So whatever we used to call transmission media or the link, okay, so what type of material they have used, okay, what type of cable they have used. So depending on the implementation of capable, the bandwidth can be increased, the speed of the data travel that can be increased. Okay, so how they have designed, what are the different techniques. So I'll just quickly spend 2 minutes. Yes, any doubts, any queries? See, attendance is very important. So if you are not regular to the class, you will lose. I am just marking the attendance from the list. I can download the attendance. So who are absent, I can mark it. I think few students already faced, they were unable to take the first IA. If you are getting shortage of attendance, so you are not allowed for the second IA also. Okay, just give me 2 minutes to go through this transmission media. So your transmission media are made up of different types of cables. Okay, so the implementation of cable is different. So how it is done, all that it is given in this chapter. That is chapter 7, guided transmission media and unguided. So that is called wireless transmission. So free space as taken as a wireless. So if it is guided, there is a type of cable called twisted pair cable. The second type of cable we call it as coaxial cable. Then fiber optic cable. Okay, so through which it can send the data at high speed and will be able to provide good bandwidth. I think most of the networks now they are using this fiber optic cable, and you can just go through all that. So how those cables are implemented. Twisted pair cable. This is an example of twisted pair cable. Okay, I'm not going to explain see how metal shield is there inside the cable. Maybe if you just view outer side, you will be able to see the black color, the plastic coating, but inside you can just see there are so many layers. And this is called as coaxial cable. Okay, there is an inner conductor, outer conductor, shield, insulator, plastic cover. The final one is plastic cover. But most of the time, if you are connected with wired internet, you can just see the thickness of the cable is little bit large compared to the normal cables. Okay. You can just go through. So what is the advantage? How exactly the signal carries? So this is about the fiber optical. This is coaxial, and this is optical cable, fiber optical cable. So in that case, how exactly the signal travels? Okay. So what is the mechanism used to implement optical fiber cable? Okay, just go through all these things. I will just leave it as a like assignment part for you people. Try to just spend some time to understand this fiber construction, how fiber cable is implemented. Okay, cladding, plastic buffer, glass. Okay, so there are different ways of implementing the physical media, transmission media. Okay, so among these, the optical fiber is the best one through which you can transfer the data at high speed. Okay, so I will leave that chapter 7 for you. So just go through. It is not there for syllabus. That's why I'm just gone through very brief. Okay, so let me move on to WDM. So it is used to this is designed mainly to use the high data rate capability. Okay, so why they have introduced WDM? So what is the main goal is to increase the high data rate capability of optical fiber optical cable. Okay, what is the type of channel link they have used here? It is fiber optical cable. So here the optical fiber data rate is higher than the data rate of metallic transmission cable. Okay, so what are the other cables I have told now? So compared to that, optical fiber will be having high data rate. It can transfer the data rate at faster rate. Okay, so here WDM is conceptually same as FDM. So except the multiplexing and demultiplexing involves optical signals. So here you are going to consider the optical signals transmitted through the fiber optical channel. So whatever the channel you can observe here, so this is designed using fiber optical channel. So what is the idea they have used here is, so combining different signal of different frequencies. Okay. So the idea used in FDM is combining the signals which is having different frequencies into a single. So here how exactly this WDM is working. Okay, what is the working procedure is used. So it is where the very narrow band of light from different sources. So the narrow band of light from different sources are combined to make wider band of light. Okay. So at the receiver side, the signals are separated by demultiplexer. So if you are taking example of prism, okay, I think everybody studied about the prism, how it works. Okay, so you can just observe. So here the prism is considered as the multiplexer. Okay, so multiplexer can be made up of several input beam of light. Okay, so whatever the input you are getting, so that will be considered as input of beam of light, each containing a narrow band of frequency. Okay, narrow band of frequency into one output beam of wider frequencies. Okay, when you are combining all these input uh, the signals, okay, you will be able to get the wider band of frequency. You can just see this is the method called wavelength. That's why the lambda is used to represent the signals, lambda 1, lambda 2 and lambda 3. Okay, when it goes through this fiber optic cable, so where it performs the multiplexing. Okay, where it performing the multiplexing. So once again you can just use the analogy of the prism. The same thing can be used to perform the demultiplexing of the signals. Okay, so here the simple technique of prism is used to perform the multiplexing and demultiplexing. Okay, so where they will be use this wavelength division multiplexing? Okay, so you need to understand. So the wide narrow band is combined into a wider band, and that wider band of the signal is transmitted through the link. Okay, so that is having high capacity. See, joining at the end moment, it is of no use. So now where they will use this WDM? Okay, the application. So it is mainly used in SONET network. So what is SONET network? I will explain. SONET network in which multiple optical fiber lines are multiplexed and demultiplexed. Okay, so SONET stands for synchronous optical network. So that is used to transmit large amount of data over a relatively large distance using optical fiber. Okay, it is a type of method used for transmitting a signal for longer distance using optical fiber cable. Okay, so that is called as SONET. SONET stands for synchronous optical network. Okay, so here the link used is made up of optical fiber cable. Okay, it is mainly designed for transmitting the signal for longer distance. Is it everybody understood? Wavelength division multiplexing. Okay, it is works similar to the FDM. Only thing is the concept used here, it is the prism method. So the third method is no queries. The third method is time division multiplexing. So now I'll ask one question. Have you people already started CPU scheduling in operating system? Yes. In operating system, have you people already started CPU scheduling problems, methods?
No, ma'am.
Okay. Okay. So in that, in CPU scheduling, you will be able to answer like how the CPU can be scheduled because there are so many multiple jobs. Okay. So multiple jobs, each process will be want to perform particular task. But if there is only single CPU, how it will perform all these tasks? Okay, as a user, you will be running so many applications. Do you feel the CPU is executing only one at a time? No, the user will feel like that all the applications are running at the same time, but internally it is not. Okay, it uses some scheduling mechanism. So in that, I think you will be learning first come, first serve, then shortest job first. What else? Priority based scheduling, and also there is one common technique called round robin. Okay, so where there will be quantum time given for each of the user. I mean each of the process. It will run if I have given 1 second to each of the process. The first process runs for 1 second and it interrupts. Okay, it will stop and it will take the second process runs for 1 second and it stops. Next process like this. Okay, once all the process finished, once again it will take the first process, give the next 1 second to perform its operation. Okay, so like that it is going to give the time slot. Okay, time slot for all the process. The CPU is not running all the process at the same time, so CPU is allocated only one process. It can execute only one process at a time. So in the same manner, so in the previous method, that is wavelength division multiplexing and FDM, so where the link is shared, okay, whatever the link capacity is there, that is shared among multiple sources. Okay, is it clear? But in case of time division multiplexing, instead of sharing the cable, I mean the capacity of the link, so allow each user, each device to make use of a particular time slot to send the data. Complete capacity of the link is used by a particular device, okay, for some period of time. Okay, so that is called as time division multiplexing. Okay, you can just look into the diagram, TDMA. So this is a multiplexer part, and this is common. Okay, only the link how they have implemented you need to check it. So you can just see it is divided into time slot. Okay, consider this is some interval t. So this interval of time it is given to device 1 to send its data, then device 2, then device 3. That's what I was explaining, round robin. Okay, then device 4. Once all the devices have got the first chance to send the data with the interval of t, next it repeats. Next it repeats for the first device, next t interval, then second, third, fourth. 1, 2, 3, 4. Okay, so this is how it is going to give the time slot for each of the device. Time slot for each of the device where it can make use of the full capacity of the link. Okay, it can make use of the full capacity of the link with that duration. No other, see, with this duration, no other device can send. Only device 1 is allowed to send the data. Okay, so once you start operating system scheduling chapter, you can just relate this method to round robin. Okay, not exactly that, but some part of the concept it is used here. What is the difference also I will tell. Okay, so your time division multiplexing is a digital process that allows several connection to share high bandwidth of link. Okay, whatever the bandwidth of link it is there, that is shared among different devices instead of sharing portion of the bandwidth. Okay, so how it is done, WDM and FDM. So portion of bandwidth was shared with each device. So here it is not the case. Okay, full capacity of the link is shared by single device, but with some interval of time. Time is shared. Here time is shared. Okay, so like if I ask any question, I will allow you any one person to speak. Okay, for some time, and I will ask another person with some time. So like that, time sharing the time. I am giving individually some particular interval of time to share their information. Okay, so the same concept used here. So each connection occupies portion of time in the link. Okay, so I told t interval. So this complete t interval will be allocated for device 1. Then t2 it is allocated for